Welcome to yet another video of Code from Scratch. So proud of you for showing up today, especially today because we are going to discuss an extremely important topic. This will help you solve a lot of questions of recursion, very important ones like permutations, combinations, and it will help you set your basics for dynamic programming. This concept will help you solve so many dynamic programming questions you have no idea. This is an extremely important topic. I highly recommend you to watch till the end, try to understand the code, take a pen and paper, sit and try to visualize. If you have any problem at all, let me know. I am here to help you. Let's get started. The question that we are going to discuss today is the power set question. So we are given a string and we have to find all possible subsequences of the string in lexicographically sorted order. So first let's concentrate on this and then we will see how can we convert our answer to lexicographically sorted order. Don't worry, I will explain everything properly. Even if you're a beginner, don't worry at all. Okay, so this is the string given to us and these are the subsequences of the string that we have to add. Okay, first we have to understand what is a subsequence. Then we have to understand that, okay, what do we mean by all possible subsequences of the string? So let's look at that now. So here this is the string given to us and this is the answer. These are the possible subsequences. First let's try to understand what subsequence means. So if you notice this here, AC is also an answer. Why should AC be an answer? Because A and C is not continuous, right? So there are two terms that you will see in a lot of DSA questions. One will be called subarray. So in a lot of questions you will be asked to find subarrays, and in some questions you will be asked to find subsequences. Now what is the difference between these two? In subarrays the elements have to be continuous. In subsequences the elements don't have to be continuous. See, in this it has to be continuous. In this it doesn't have to be continuous. Let's see how. So in ABC string itself, if we see AB is a subarray as well as a subsequence. But if we see AC, it is a subsequence and not a subarray. Now notice when I said that AB is a subarray as well as a subsequence, but AC is a subsequence and not a subarray. Why is that? See, in subsequences, it doesn't have to be continuous, but it can be continuous. Let me say that again. So if we say AB, it is continuous. So yeah, it is subarray, but it is not like because it is continuous, it will not be subsequence. It is not like that. So in subsequence, it can be continuous or it cannot be continuous. Like maybe or may not be. You don't know. Okay. But in subarray, it has to be continuous. So that is the difference. So if we say we have some A, B, C, D, E, then the subarrays are like B, C, D is a subarray, C, D is a subarray, only A, only B, only C, only E, D, E, all of these are subarrays. And these subarrays are also subsequences. But if we see something like A, C, E, so this is a subsequence. It is a subsequence, but it is not a subarray. So I hope you have understood the difference between subarray and subsequence by now. Now let's move on to understand that what are all the possible subsequences of a given string. So if you notice, the question was called power set question, right? Why is it power set? So power set is basically a set of all the possible subsequences of a given string. Okay, this we have actually studied in school. So we if you remember or not, I don't know. For those of you who remember, let me know in the comments what are the number of subsequences that are possible for a given string. If you don't remember, it's fine. We are going to try understanding it now. Okay, so if say ABC is there, so what are the possible sizes of the subsequences that are possible? So say we can pick up one element, then we can say we can pick up two elements, we can pick up all three elements together. There's also one possibility that we pick up 0 elements. So actually when we see power set now, so in power set there is one more element which is like empty. So that means you are picking up no elements at all. Sometimes in the question this empty subsequence might be included, sometimes it might not be included. So length 0 in the question that we are dealing with, it's not included in the output. So that is why we are not going to include this today. Okay, so this is an important point. This is a question that you can ask your interviewer. Should you include like null set? Basically there no elements are included. That is also a subsequence, right? Because you're not including any element. So some people might include that in this power set, some people might not include it. By definition it should be included. So you can ask an interviewer that okay, you want it to be included or not, but in the question that we are given it is not included, so we are not going to take it. Okay, now let's see what are the subsequences possible of length 1. So length 1 means we can pick up only one element. So we can pick up either A, we can pick up C, we can pick up B. Okay, similarly of length 2 we can pick up AB, we can pick up AC, we can pick up BC, like this. Okay, for length 3 we can only pick up ABC. So similarly if it would have been ABCD, so you try writing it yourself. So for length 1 it will be ABCD, length 2 it will be AB, AC, AD. Okay, One more thing to notice over here. So AD I can write, but I cannot write DA. So basically it should be in the same order in which it is present in the string. Like this here, see, BC is a subsequence, but CB should not be a subsequence because the elements that are there, so ABC should be in the same order as the string itself. So I recommend you try writing this and see the number of the subsequences that are there. So here, what are the number of subsequences? It is 7. And if we see this empty one also, it is 7 plus 1, it is 8. For string length is 3, we saw that, okay, the number of subsequences is 8, including the empty one. For length 4, you will see that, okay, it is 16. For length 5, it will be 25. Try writing this and see. So what is it that you are noticing? That you are noticing that if the length of the string is n, then the number of subsequences is 2 power n. Why is this? Let's talk about this now. Quick revision, what have we seen till now? The differences between subsequence and subarray. In subsequences, the elements don't have to be continuous. It may be continuous, they might not be continuous, okay? Then we saw what are the possible subsequences of a given string. So for this, we have to consider the subsequences of all lengths, 1, 2, 3, 4, so on up to n. Then we saw that for a string of length 3, the number of subsequences were 8, including the empty subsequence. And I said that, okay, for string 4, it will be 16. Then for a string of length 5, I think I said 25 by mistake. It should not be 25, it should be 32. Let's take more examples so that it is more clear and you're not confused. Sorry for that confusion. For length 1, it will be 2. For length 2, it will be 4. How am I calculating this? Let's talk about that. Basically, I am saying that for any length of string n, the number of subsequences possible should be 2 power n. If you want to take some more examples, say we had only a string a, okay? So what are the possibilities that we don't pick up any element? So that is one, that was the empty one that we had discussed. Then the another possibility is that we pick up the element. So the size of the power set or the number of subsequences possible is 2. Similarly, say we have AB, then it is possible that empty one, then we pick up A, we pick up AB, then we pick up B, then we pick up AB. So 0, length 1, length 2, like this, okay? So number of possibilities is 4. Similarly, ABC, we saw number of possibilities were 8. And say the characters don't have to be different also. If the characters is same, say if it is AA, then it can be empty, then it will be A, then it will be A, and then it will be AA. Why is this? Because this A denotes this and this A denotes this. So that is why these are two different subsequences, because the A's that we are dealing with is different, okay? Now let's try to understand why this is true. See, for every element in the string, for every character in the string, there are two possibilities. One possibility is included in the subsequence. Second possibility is excluded in the subsequence. That means don't include it in the subsequence. So if we see this, the subsequence A. So in this A was included, B and C were not included. Similarly, if we see EB, so A was included, B was included, C was not included. See, A, B, C, all three were included. AC, this was included, B was not included, C was included. Similarly, if we see B, A was not included, C was not included. If we see B, C, A was not included. If we see C, A and B were not included. See, for every possible element. Similarly, if we want to see for empty one, all three were not included. Here all three were included, here none of them were included. So basically, for every element, for every character in the string, there are two possibilities, to include it and not to include it. So there are n characters. For every character, there are two possibilities. So 2 possibilities for the first character, 2 possibilities for the second character, 2 possibilities for the third character, and so on, for n times, right? So what are the number of possibilities? It is 2 power n. See, if we had 3 elements, for each element A, B, C, there are 2 possibilities, included or not included, included or not included, included or not included. So 2 into 2 into 2, so number of possibilities is 2 power 3, so it is 8. So this is what we had actually studied in school also. The number of possible subsequences is 2 power 3, 8. Basically the size of the power set is 2 power n. So this is an extremely important concept, because this is going to help you understand time complexities for a lot of algorithms and a lot of code. So you should be completely clear with this. So wherever we have this option that include an element or not include an element, the number of possibilities is 2 power n. And this will actually help us understand the time complexity in a lot of. Now let's try to draw a recursive tree and try to visualize that, okay, how are we going to find the possible subsequences, okay? So if we have this string ABC, let's just start moving from first element. So if we take this first element A, so there are 2 possibilities for this. Either pick up the element or don't pick up the element. So if I pick up the element, A is one possible subsequence, and if I don't pick up the element, empty is one possible subsequence. Now if I come to B, now when I have A, from here also now I'm dealing with the element B. Now here there are two possibilities. Either I can include B on this. So if I include B, it will become AB. If I don't include B, the subsequence will remain A only. Similarly, in empty one, if I include B, one possible subsequence becomes B. And if I don't include B, the empty one will be there. Okay. Now let's come to the third element C. So when we have the third element C, if we include in this, then the subsequence will become ABC. If we don't include in this, then subsequence will be AB only. See, if we include in this, it will become AC. If we don't include in this, it will remain A only. If we include in this, it will become BC. If we don't include in this, it will become B only. If we include in this, it will become C. If we don't include in this, it will become empty only. Don't worry if it's not clear. We will discuss this in detail. But this is an extremely important diagram. You should be able to understand this thoroughly. So if you have any doubts, let me know in the comments, because this is really important. See, first thing to notice, at this level, we were dealing with only one element. So what were the two possibilities? The number of possibilities were actually 2. So at any level, if you see, so here we were at second index. So basically number of elements that we were dealing with were 2. So the number of possibilities were 4. 1, 2, 3, 4, right? So 4 possibilities. Similarly over here, we were dealing with third element. The number of possibilities were 8. Again, see, from here we were seeing that from n elements, we are seeing the number of possibilities as 2 power n. And that is why when we tried drawing the recursive tree also at any level, so if you are dealing with n elements, the number of elements at that level in the recursive tree will be 2 power n. And this was actually our answer for the question. So if we see, we have A, then we have B, then we have C, then we have AB, AC, BC, and we have ABC also, and we have empty one also. So we have all the possible subsequences if the length of the string is 3, ABC. That is why the number of subsequences that we have got is 8. So this is the recursive tree visualization that we are going to use to try writing the code also. So I want you to try writing the code yourself. We will be discussing it tomorrow, so don't worry at all. But this is what we have to do. We will go through the string element by element. So basically we will start from the first element. Then we will go ahead with the string. And for each element, we will have two options, either include it or don't include it. So try visualizing this. So we did for ABC, try visualizing it for ABCD, try for AA, try for different strings and see if you're able to draw the recursive tree or not. What we will do tomorrow is we will try writing the code. So this is the question. You do show up tomorrow because it is again extremely important topic. See you. Bye.